Calculus. If I had to simplify what calculus is, I would say that it's a branch of math that deals with things that are infinitely large or infinitely small called infinitesimals. Personally, I would divide the fundamentals of calculus into three parts: the derivative definition, the definite integral definition, and the fundamental theorem of calculus. But to keep this video short and simple, we will only discuss the first definition, the derivative, which is the slope of a function at a single point. Before calculus, many mathematicians knew that the slope was equal to the rise over the run, which is a problem, because if we were to have the 2 points at the same place, the slope would be 0 over 0, which is undefined. This stumped mathematicians for many years. We knew that as the 2 points got closer, the slope would get closer to becoming tangent. But the moment the 2 points occupy the same place, the slope becomes undefined. And we obviously know that isn't true. So how did mathematicians overcome this problem? Well, earlier we discussed that as the 2 points get closer, the slope gets closer to becoming tangent. So let's rewrite the slope equation with y as a function of x, and have the distance between the 2 points equal to c. That way, as c gets closer to 0, the slope gets closer to becoming tangent. But if we have c equals 0, we still run into the same problem as before. So how does rewriting this equation help us? Well, what if we had c approach 0? In Chapter 1 of Calculus, you learn about something called a limit. And it basically allows us to sort of bend the rules by asking the equation, what value will you be as we approach that position? By doing this, we can now treat c as a variable. So instead of getting 0 over 0, we can now rewrite the question as, what is the limit as x approaches 0 of x over x, which can now cancel to just 1. By allowing us to think of 0 as an approaching placeholder, we have overcome the problem that has stumped mathematicians for many years. This concept may seem absolutely ridiculous, but the idea of having points approach a specific location completely changed math forever, and created the early building blocks of calculus. By having the distance c approach 0, we can now find the tangent slope of any function, giving birth to the derivative. But why is this important? Why should anyone care about this? Well, let's apply it to the real world. Suppose we plotted a car's movement on a distance versus time graph. If we were to find the slope of this function, we will find the car's average speed, or velocity between time A and time B. And the reason for this is the slope is equal to the rise over run, or in this case, the distance per time, which is velocity. Finding the tangent slope, or its derivative, will give us the instantaneous velocity of the car at any given frame of time, which is pretty crazy if you think about it. This is why you hear calculus, or the derivative, has to do with rates of change. If we were to drop a ball, its position versus time function would be parabolic, because gravity is accelerating the ball downward at 9.8 meters per second squared. With a little magic, we can formulate its position function to be negative 4.9 t squared. If we were to take the derivative of this position function with respect to time, we will get the ball's velocity as a new function of time. And if we want to find the ball's instantaneous velocity at any point in time, you just plug the time into the new velocity function that we got from taking the derivative of its position, which is super useful for physics and engineering. And that's just scratching the surface. I hope anyone new to calculus found this useful. Peace.